Okay, we'll get to work without further ado on replacing these right angle headers on the Ultimate 1 megabyte with standard upright headers, straight headers. Okay, so let's firstly snip these connectors apart so that we can slide them off the pins. I'm going to snip them with my little cutters here. It just makes it a little easier to slide these things off the end. Push them off with the end of a screwdriver, hopefully. See what I'm doing. Move these wires. I was making cables at the weekend, so there's a mess. There we go. These things are a real pain to get off. Apologies if there's any weirdness about the audio quality. I'm using the microphone I got from China because I'm sick of wearing that full headgear thing, and I'm still waiting for the FM wireless transceiver. So I've just got this microphone plugged straight into the PC, so I'm still tethered to the PC, but it's even without the even though it's not wireless yet, it's still preferable to having that other contraption on my head. But time will tell whether or not it sounds as good. So I know it would be better if I worked so you could see what I was doing. So basically just pulling these smashed up bits of plastic off the ends of the pins, like so. I'm going to turn the soldering iron on, let that warm up. While I'm waiting for that to warm up, I'm going to get rid of these bits of plastic. So this is what you should be left with. And we'll put that in the bin. And then we'll get some flux on here. Now, need some more flux as well. This syringe has never ever been any good. Need about 200 pounds of pressure on the plunger to get anything to come out of it. But the reason I like to put flux on here is because this will be probably, I'm assuming, I'm not sure, this is probably lead-free solder on this board, so what we want to be spending as little time as possible doing is resting the iron near any of these wires. Oh, focus. Because these, I mean, the board's good quality, but I've realised what the limitations are. The limits, realised the limits of endurance as far as heat are concerned. Because I've replaced the headers on about half a dozen of these things. And the first time I did it, I cooked one of the plate throughs on here a little bit. Just not enough to break it, but enough that I had to get the multimeter out afterwards to satisfy myself that I hadn't destroyed it. So now start to get rid of these pins. So I'm just going to stick that on the table with a bit of ESD safe blue tack. And what temperature are we on here? 400 and 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 Where are we? About 420 degrees on the iron. Okay. And we're going to pick these little things off the board and then clean out the holes. But before I do that, I'm going to try and find the pliers, wherever they are. What would I have been doing? I mean, I could use the tweezers, probably. Probably could use the tweezers. So what I'm gonna do is I'm gonna zoom in a bit here. I'm gonna zoom in. Hope that the Logitech webcam driver doesn't crash, as it usually tends to do. Okay, crappy digital zoom on. Apply heat. Ah, this is no good. I need the proper pliers. Where are they? Where have I put them? I haven't put them back. Where the hell? Slid under here. Nope. The whole idea with this was to make a video that I didn't have to edit. And oh, yeah, they were right in front of my eyes. Yes. Okay. Just make sure you can see this. Right. Start again. So just apply. We're not putting the iron anywhere near the board. We've got the iron a couple of millimeters away from the end of the pin. There we go, it's finally come out. I think the iron's a bit too cool. Okay, next one. So, heat the pin, not the board. Heat the pin, not the board, and there we can see they're starting to come out, no problem. There we go. The iron it's on the shoulder of the pin. Just below the shoulder of the pin. I should probably not put I should probably use a different tip. So the chance of overheating the board is very, very slim because the iron is not touching the board at all. We're going for minimum stress on the board, because if you break these wires, it's not going to be fun. There we go, come off. Yep. This is where the flux comes in, because now this one is tricky because there is hardly any solder on the. Actually, I'm going to zoom that out. This doesn't look very good at all. I think it'd be better if I actually moved the camera. Zoom out. zoom out, see if we can move the camera so you get a better look at what's going on. Let's see. Right, that's better. Let's see what's what. So, as I say, this pin that I'm working on here, this one here, has hardly got any solder visible on that side of the board, so I'm just going to add a little bit more. And you can see that that has caused the heat to conduct more efficiently. So now when I heat up this leg again on the shoulder, it's going to come out no problem at all. Next one. There we go. If it's not coming out after about 2 or 3 seconds, yeah, I've had to go. If there isn't much solder on the top side of the board, you're going to have to either add more solder, or you're going to have to go in a little bit lower with the iron. But that's okay. A little bit more flux on these front row pins. Should probably move around a little bit, so we're more sort of in this position. That's better. Yes, that's a bit better. The angle's a bit low, so it'll be autofocus all the time. Never mind. So next one. Yeah, come on. There we go. Heat. I think the biggest problem I've got here is the fact that the board's moving around in this stupid lump of blue tack. I should get some sort of proper clamp. Right. Okay. Heat. Heat there. I had to touch the pad there because it just didn't want to go. Right, that's it. The reason it's awkward is because most of the solder is on the back side of the board. So if you add some leaded solder, I'll take this one off first, it's in the way. Most of the solder's on the back side of the board, so really ideally you probably want to be heating this from the underneath. But that's a bit too fiddly for me. There we go. So yeah, I've more solder on, so it's much easier. I mean, you could probably get these off with hot air, but I'd be worried about scorching the board, personally. Although I have not tried it. I have not tried it with hot air, but no reason why it wouldn't work. But I don't want to destroy a board trying air. If I had an old board that I didn't mind messing up, I would try it with the hot air. But no, I've got enough flux on there. Alright, let's go. But well, this works perfectly well. Just takes a little bit longer. Come on. Well, the second one's ready to go already. I don't need more solder on there. No, this one will come straight off now that there's more solder on there. twist this one around a bit. Oops, there we go. There we go. Okay, nearly done. Right, that's it. All the pins out. Oh, just nearly strangled myself as I leaned across the desk with the microphone wire. Where is the transmitter? I hoped it would come today, but it hasn't. I'll throw those pins away. Now let's get this thing cleaned up. Alright. Right, as you can see, as you would be able to see if it would focus, that's the underneath of the board, and lumps of solder that we're going to have to, now that is lead free solder, which is going to have a higher melting point. So trying to remember which way I usually tackle this actually. I mean, you could put the thing this way on. I'll try it this way on. See what happens. So just use a bit of guesswork to line the thing up. There we go. I'm going to put some more flux on this side of the board. It would probably be worth adding some leaded solder first. But we'll see how we go. You don't want any unnecessary effort. Just iron on the middle of the pad. The instant the solder melts, we hit the button. So that one's not going to go. So I've had 2 tries at that one. It doesn't want to go. So that is the signal that we need some more solder. Which I probably threw away with the pins. Right. A little bit more solder on here. This lead-free stuff's just awful. I'm going to tin all of the holes with the leaded solder, so we've got something to heat up. We've got something to heat up without having to press the iron down on the plate on the via. So we heat the solder and not the board. There we go. Right, let's have a close look. Okay. That looks reasonably good, but as you can see, I'll get the screwdriver. With these two here, oh, they are just about ready to go. I've just flattened them down again with the edge of the screwdriver. I'll dial the iron back down a little bit to 400 degrees. So that's a bit too close for comfort, but we'll clean that up, and I think we'll find that we've still got continuity on the trace that's going up over. Okay, so with a little bit less heat, we're going to do the other side now. Okay, same thing on this end. The slightly cooler iron. Add a bit of solder on all of these. So you are basically not very far from destroying these wires at any one point, at any given point, I should say. So that's why I need to be quick. We did clear two at once there. Alright, finally. This looks reasonably good. Might have to clean one or two of them up a little bit more. But yes, it's a bit of an adventure every time. When we've cleaned it up, we'll get a better idea of whether or not that other trace got damaged. I don't think it did. I don't think it did, but we'll see. Okay, so let's have a little look. See what we ended up with. So yeah, although that that was a little bit damaged, but It's still got continuity, there's no question about that. That's still fine. And then the other end of the board, underside of the board, and the top side of the board, everything's still intact. I think here, I think that one's still a little bit clogged with solder, and possibly the one next to it. Yeah, definitely the one next to it as well. And they were very stubborn anyway, so we'll just do add and take away again on that, on those ones. Once that lead-free solder's gone, it's it makes a hell of a difference. Okay, so I've found the connectors for I found the IDC connectors in the cupboard, and when I came back to the desk I forgot to put this microphone back on. So there's going to be an edit, which I didn't expect. So the bit that you missed was when I put that connector fitted on straight away without any problems. Make sure you get the orientation right. When it came to this end here, you could tell there was resistance on a couple of these pins, and when what will happen is if you continue to push the connector in when there's a couple of holes that aren't clear of solder, the pins will actually push out the top of the connector, so you can see. But actually, if I'd looked properly up against the light, I could have seen there were a couple of holes here that still weren't fully clear, so we put some more solder in. Used the pump again to get the solder out, and as you can see, this now pushes in without any problems whatsoever. And all that remains to do is to solder the back. You can have a look, see what it looks like. So we'll solder the connector on, but inspect the traces, inspect everything before you put these on, because if you put these back on and then it doesn't work when you come to plug it all in, it's going to be a complete nightmare. It'd be far better to clean this up, make absolutely sure that nothing's been damaged. If you're not sure, in the case of that one, if that had lifted really badly, I'd get the meter out and test the trace, but it's obviously fine. So once it's all soldered up, no one will ever know. So that is how you replace the right angle pins on, or this is how I replace the right angle pins on an Ultimate 1 megabyte with IDC boxed headers. If you have a different way of doing it, or if you have any more questions about this, please write in the comments, and I shall see you all next time.